This is a second part of the Computerized Medical Equipment Management System, or CMEMS. In this part, we'll have a practical example to demonstrate what is a computerized medical equipment management system. This example will be about the HEMS system, which is developed by the EQ2. And we will cover these points. Then we will talk about the planning for a new computerized medical equipment management systems and the points which we should consider during the planning for such system and how to implement this system. Now we'll start with this practical example. These systems have evolved over time. After the IBM PC introduction in mid-1980s, a system based on a PC database started to appear. An example, the computerized medical equipment management system for which was developed by the University of Vermont. This system is called Hospital Engineering Management System, or HEMS. Um, it was founded in 1985. We can see here a screenshot for the main page, which have been used from 1985 till 2010. In this slide, we see the new software for the HEMS in 2017. This is a screenshot for the main page. As we can see, we have different modules. We have the work orders, generate schedule, assign work orders, equipment inventory, equipment types, equipment models, schedules, procedures, parts, reports, and so on. The HEMS system consists of data on the medical equipment inventory and the work information, and the work information, or what's also known as work orders, can be separated into scheduled and unscheduled, and also we have other information, all combined to create a complete history for each medical device, as we will see in the next slide. So we have firstly we have two type of maintenance. We have in-house maintenance, or clinical engineering services, hospital clinical engineering services inside the hospital, and we have out-house services or vendor services. The work orders are for the in-house services will be generated. We have two types of the work orders. We have unscheduled work orders due to unscheduled work requests, and we have pending scheduled work orders generated by the PM scheduler of the computerized medical equipment management systems. So we have different inputs, as we can see here. For the work order control, we have from the pending scheduled work orders and unscheduled work request. We have input also from parts and equipment inventory. The output of the all of the work order control will be the for medical equipment history. Also, the medical equipment history have different inputs. One of them is the work order control, which is generated by the in-house staff, whereas we also have work orders or vendor service information, which considered as out-house services. We have the equipment inventory. So the medical equipment history will be first the second step, and based on this medical equipment history, reports will be generated, which is the essential point behind this computerized medical equipment management system, which help us to reduce cost, to improve the quality of the care, to perform a lot of tasks, which we'll talk about in the next slides. Now we'll see a short, we will watch a short video about the HEMS system. So it's an acronym for Hospital Engineering Management System. We have different stuff which helps to generate such computerized medical equipment management system. And it's also the reports generated by such system will be useful for different types of the staff, as we can see here, starting with the vice president and ending with the clinicals. So one of the features being secure and real time. So we can updates in a real time. Also, one of the important, we will see important features of the HEMS system, which include for first the integrations with the HES system, which is very important and essential. The integration or interoperability with the medical devices based on the IHE, which is the International Health Care Enterprise. Also, another feature of the HELM system is the RTLS, which is an acronym for the real-time location system, the network information, also the electronic patient health information checks. Also, the communication with the patient, the connection directly to the patient or EMR or the electronic medical record of a patient or electronic patient record. Also, one of the features of the HEMS system is the ability to connect with the electrical safety analyzer or biomedical equipment testing and other features. Also, another feature which is very important concerning the HEMS system, and we will see this later, it can work either as offline or online. As we said before, usually most of the commercial computerized medical equipment management either can be offline or online. The HEMS has the capability of being installed as offline and online. So cloud or hospital server. So this is a short brief about the HEMS system. Now we'll talk about the different parts of this HEMS system. We'll talk firstly about the medical equipment inventory. Then we will talk about the maintenance information. Then we will talk about the reports generated by such computerized systems. So now we'll start with the medical equipment inventory. There are different types of data which are related to the medical equipment inventory. This can be classified as either essential data, additional data, or network connectivity. Essential data is can be a unique identification number, device type, manufacturer, model, serial number, and so on. Additional data could be a photo which is taken for this device, the life expectancy, the service contract data, software version, the MAC address and IP address, purchase order number and PDF, and so on. The network connectivity will becomes now essential due to the connectivity needed with the medical devices and with the hospital information system. So such information or data will include the IP and the MAC address, the host, the gateway, the masks, antivirus, duplex, and other information. As we can see, this is an example of the type of data. This is a screenshot which has been taken of the inventory information. It includes some of the essential data and as well as some of the other data. we can see here an example of the connectivity data, as we said before, the IP address, the MAC address, the DHCP server, and so on, the port number, and so on. Also, important point concerning the medical equipment inventory to have a standardized format. Talking concerning the standardized format, we should talk about the FDA initiative and the nomenclature which has been used based on the requirement of the FDA initiative. It's essential that the data fields to be input in a standardized format using a systemic approach to the nomenclature. Why this is important? Because in case we have a recall device and we should search for it in our medical equipment inventory, this will be even missed or very difficult in case we don't have a standardized format. So in 2013, the FDA put forth the final rule related to the requirement for a unique device identifier for medical devices, which also known as UDI. The identifier contains unique device and production data. This rule mandates companies use the UDI system in stages. The first stage will start started in September 24, 2014, and this will be ended in September 24, 2020. This is an example of the UDI, which is proposed by the FDA, or which has been initiated by the FDA. Now we'll talk about the second part of the HEMS system. So the first step will be the medical equipment inventory, the establish of such medical equipment inventory. The next step will be the maintenance information generated related to this medical equipment inventory. This information can be separated into two parts: scheduled maintenance and unscheduled maintenance information. The scheduled one will be separated into routine inspections, or known as IPM, inspection and preventive maintenance procedures, and special inspection procedures. The scheduled maintenance is at the core of the computerized medical equipment management system use due to the cost and resource factors. A key part of the maintenance is to automate this, to automate the preventive maintenance and inspection program due to the large number or the quantity of medical devices and the differing requirements for intervals and tasks. Example, in the case of a hospital or even a medical center with a large number of medical devices in its medical inventory, this task will be very difficult to make a preventive maintenance schedule and to assign this task to staff in the clinical engineering department. So having a computerized medical equipment management system will automate this process and will make easier for the staff and will save a lot of time and cost. So as we said, this maintenance information will be separated into scheduled and unscheduled one. The scheduled also will be separated into routine and specialized. The routine, the information or the element which we are needed in addition to the procedure schedule and the equipment will be the parts required, the spare parts required in the IPM or the inspection and preventive maintenance, the biomedical testing equipment or testing equipment in general, also staff skilled required, and finally the results. The task included in the routine inspection procedures will be a general physical checkup, an electrical safety also checkup based on a standard such as the IEC 6061-1. Also will the routine tasks such as filter cleaning, visual inspection, and so on. This is an example of the routine tasks which are performed in a scheduled to prevent routine scheduled maintenance procedures. In addition to the routine one, we have the special inspection procedure, which they may have, for example, some devices may have custom self-test to be administrated, uncommon measurement procedures, or even a specialized parts replacement. In this case, this is considered as a specialized or special inspection procedure, and this is a part of the scheduled maintenance information. Now we'll talk about the second part of the maintenance information, which will be the unscheduled maintenance. The unscheduled maintenance work includes repairs, incoming inspection in case of a new equipment has been delivered for the hospital. In the case of hazard alerts and recalls, updates for the equipment, modification of some equipment, installations, and other work that is not scheduled. So the unscheduled work will include repairs, incoming inspections of new equipment, recalls, updates, modifications, and installation and other work that is not scheduled. Repairs will be the majority of the typical medical device life cycle maintenance cost. So the repairs will be the represent the most of the costs concerning the medical device, a typical medical device life cycle maintenance cost. As for this, we should consider this cost concerning the labor, parts, and shipping. Another point, the failure rate associated with the repairs is also an important reliability measure. So the problem type and resolution need to be documented, typically with a code for searching and test description to show the specification related to this problem. Why this important? This will be important in the generating of the reports and the analysis of reports in order to take actions. Here an example of some maintenance code example for common problems such as random failures. This is a code in case if we have a random failures, maintenance related and battery replacement may be also used. This is an example of unscheduled work order in the HEMS system. In addition to the information related to scheduled and unscheduled maintenance information, we have non-maintenance information. Such information will include the assessed data on purchase cost, depreciation, and parts, risk management data on the user errors, incidents, and recalls, data to support the purchasing function, such as the parts data for ordering, inventories to assess future purchases, and finally, functional information. For example, major medical equipment items for state agencies. So we have started with the establishment of the medical equipment inventory. Then we talked about the maintenance information related to during the life cycle of this devising of these medical devices, which is the maintenance information. Now we'll talk about the last point, which is which will be related to the maintenance information as well as the medical equipment inventory, which will be the analysis and the reports, which is the idea behind the computerized medical equipment management system. We have different types of reports which will be used and by different type of staff or healthcare staff. For example, we have reports generated by the computerized maintenance management system will be related to the administration. We have other type of reports will be related to the clinical staff, risk management, facilities management, regularity compliance officers. For example, in the case of the administration, we have reports related to the medical equipment replacement, the downtime, the cost of labor and parts, charges to the departments for hospitals that use a chargeback system, and so on. For the clinical staff and risk management, we have reports related to the use errors or no problem found, and incidents, damage, abuse, and so on. In the case of the facilities management, we have reports related to the maintenance schedules and procedures, interactions with support departments related to the work, reliability, and finally, device histories. Concerning the reports for regularity compliance officers, we have the results related to the accreditation requirements, such the requirement are needed by regularity compliance and joint commission. Now we'll see some examples of these generated reports. The first type of the report, the first example will be about the medical equipment downtime result. Downtime can be related or can be has an impact on the patient care. For example, in the case of a physiological monitor or defibrillator, so it will be compromise the patient care. Other results or impacts of the equipment downtime or the medical equipment downtime will be the cost that are lost or the income lost, the lost income. This cost can be vary based on the equipment. We have the essential equipments in the hospital, which are found in the laboratory and imaging, as well as we have the complex systems such as a robotic surgical system. The downtime for such the system will mean the loss of big income, and this will be has impact on the balance sheet for the hospital. For example, in the case of the laboratory equipment exams are low in cost, but high number will make the cost higher. For example, the test will be around, for example, $10 or $7, but we have large number of tests will be performed in the laboratory equipment. If we taking the example of the imaging exams or test, are higher individual cost ranging from the $100 to $1,000, and the cost will be even much higher in the expensive system or medical device systems such as the robotic surgical system. This will be cost of $10,000. So this is an example of the cost of the test in the laboratory, the services in the radiology, in MRI, CT scan, PET scan. As we can see, this is the cost, and this is the cost for the hospital, a charge for the hospital. This will be the charge for the professional physicians, radiologists, and laboratory physicians or doctors. And this will be the total charge loss due to the, in case of we have a medical equipment downtime. So downtimes, as we said before, means money. Exam charge data from this exam charge data has been taken from the University of North Carolina hospitals. So the second type of the reports, which is generated by the computerized medical equipment management system, will be the workload balancing. So another advantage of the CMEMS is the analytics included to perform tasks such as distributing the workload associated with PM inspection program. As we said before, it's very difficult to make a preventive maintenance schedule for a hospital or a medical center with a large number of medical devices, and what will be more even difficult will be the assigning of these tasks generated by this IPM schedule with the staff available in the Clinical Engineering Department. For the thousands of devices with differing schedules and requirements, the resources must be balanced, okay, between the staff and between even the available testing equipment and so on, and the PM schedules. These resources include the medical equipment safety and performance testing equipment, as we said, and most importantly, the staff work time. So we have three elements. We have the medical devices in the PM schedule. We have the medical testing equipment, which are also limited. We have also the limited number of staff. We should make this matching. Trying to make this matching manually will take a lot of time and consume, and this will cost a lot of loss or will be expensive concerning the cost for the clinical engineering department. Having a computerized medical equipment management system, all these tasks will be done more fast, more efficient, and will save a lot of money. Another type of generated reports by Computerized Medical Equipment Management System is the Safety Committee Quality Groups. Now we'll see two types of reports generated to the Safety Committee or Quality Groups. The first one will be general, concerning the work order generated, the reason behind it, and the analysis during a 4-month period. Then we will have another report which generated the number of the work orders generated based on a specific devices, which will be more useful. This one will have will help the clinical engineering department to take general actions, whereas the second type of the report, which we see in the next slides, will help us to take actions on concerning specific devices on the hospital or a medical center. So as we can see, these are the number of the work orders generated in a 4-month period. The reason behind these work orders can be either maintenance, use error, damage, or no problem found. As we can see here in this chart, that the higher number of work orders was the result of no problem found. So we should take actions based on the reason behind these work orders, and this another, as we said, then another type of report generated for the safety committee. This concerned this based on the work orders generated based on a specific device and what is the percentage available. So use error and no problem found work orders by device type. As we see different types. We see ventilator, fetal monitor, patient lift, ECG machine, and so on. It's recommended that the percentage of the work order based on the user error or no problem found shouldn't exceed 10%, as we can see in this work order chart. Based on a specific devices, most of the devices are below this percentage, which means the performance for this department is good. So this data is more specific than the previous trend graph, which shows the work orders in 4-month period, because it focuses on device types, as we see on a fetal monitor or a ventilator or CG machine and so on. The criteria, as we said, shouldn't exceed 10%, and as we have seen that all the devices have not exceeded this percentage. If the devices types were over this limit, which will be the 10%, then either staff training, reviewing techniques, or human factor aspects of the device should be considered. So after we have a practical example for computerized medical equipment management system, which was the HEMS. Now we will talk about the planning and the implementing a computerized medical equipment system for a new department or for new users or new clinical engineering users. If we have for example, if you have a clinical engineer who has never had a computerized medical equipment management system to help run the clinical engineering department, or using the basic tools such as the spreadsheets, the Excel sheets, then this person should learn about this system to be able to plan the acquisition of the computerized medical equipment management system and to implement it effectively. Also, we should analyze the current practices of this engineer and see if they of this clinical engineering department, and if they fit with the computerized medical equipment management system. What are the factors which we should consider when we are planning to for the acquisition of computerized medical equipment management systems? Some of the factors include the ease of use, especially speed and accuracy of data entry. Another point will be the functions and the features, the number of facilities and departments that can be supported, for the system, update history, web-based capabilities, interface capabilities with the hospital information system, as we said before, the data format, the SQL output. This is important, especially if we have a limitation in the type of the reports generated by this computerized medical equipment management system. Then the reporting, the handheld netbook capabilities for the mobile needs, in case we have different sites or multi-site case of hospital or medical center. Test devices interfaces. All these points we have talked about with the HEMS. We should have, as we have seen before, that the HEMS has the capabilities for the connection with the health system, with the medical devices, with the testing medical equipment, with the PHI or the electronic patient health information, and so on. So these points should be considered when we are talking about the planning for the acquisition of a new computerized medical equipment management system. Also, in the third part, I will talk about the computerized medical equipment management system and my proposal concerning the application of big data and the artificial intelligence for the computerized medical equipment management system, and how this will help to enhance the healthcare technology industry. Finally, we'll talk now about the implementation advices for this computerized medical equipment system. In general, the hardware should not only be the limitation for such, and we should consider, as we said, the software, the workflow, the processes, procedures, and reporting also should be considered when we are talking about the acquisition or the planning for a new CMEMS system. Also, great expectations are not achieved if the system is not planned for or implemented correctly. Finally, the implementation phase can be daunting in case we have a large number of the medical devices for a starting up system in a new hospital or a medical system. We, for example, data conversion, training of staff, hardware needs, interfacing, and so on. This will be very, very, very difficult and daunting for a large hospital starting up system. Finally, thank you.